morning, afternoon, evening, from wherever you're watching. Welcome back once again to the Mickey Mouse Class, a channel solely dedicated to demystifying mathematics. All right, today we'll be looking at examples on indices, on problems that have or how to solve indices, problems that are related to indices. All right, in our last class, we looked at the laws of indices. You can check out the series on the laws of indices. So let's take examples straight up. The first one, simplify 5 raised to the power of 7 times 5 raised to the power of 3. The first one borders on the multiplication law, and the multiplication law says that when we have something like this, it's the same thing as adding the powers. So 5 raised to the power 7 times 5 raised to the power 3 is the same thing as 5 raised to the power 7 plus 3. And 7 plus 3 is 10. That's 5 raised to the power of 10. We take another example. The second example on division law. Let's say 3 raised to the power of 4 divided by 3 raised to the power of 2. It's the same thing as subtracting the powers. So this is 3 raised to the power of 4 minus 2. And 4 minus 2 is 3, is 2. 4 minus 2 is 2. So 3 raised to the power 2, you can further simplify it down, is 9. The third example, 4 raised to the power of 3 raised to the power of 5. Now this example, when you have a power, a number raised to a power, which is raised to another power, what our law says is that we should multiply the powers. So this is 4 raised to the power of 3 times 5. And 3 times 5 is 15. So this is 4 raised to the power of 15. Now, the fourth one, you can have the 6 raised to the power minus 3. Remember the law? This is the negative index law. And it says for us to solve it, we have to write it in a positive form, taking the reciprocal of this and writing the power in the positive form. So this is the same thing as 1 over 6 raised to the power of 3. When you see a question like this, take the reciprocal, the power becomes positive. Now this becomes 1 over 6 raised to the power 3 is the same thing as writing 6 times 6 times 6. That's 6 in 3 places. And that's the same thing as 1 over 216. 1 over 216. So 6 raised to the power minus 3 is the same thing as 1 over 216. Alright, so we take the fifth one. The fifth one says 27 raised to the power of 2 over 3. Remember this law, the fractional index law. Now, it's the same thing as taking the root of what is here, which is the same thing as the cube root of 27, then raise it to the power of the denominator, and the denominator is the numerator. Raise it to the power of the numerator, which is 2. In our class, we said that cube root of any number is which number will multiply 3 times to get this. What is that number? Is 3. Cube root of 3 is 3, because 3 times 3 times 3 will give me 27. Now, cube root of 27 is 3, then this power, which is the same thing as 9. 3 raised to the power 2 is 9. Okay, let's take the sixth example. You can have something like this, 4 raised to the power minus 3 over 2. Now, it's the same thing as the fractional index. The only difference is that the numerator has minus. So this is the same thing as taking the square root of 4, raising it to the power of minus 3. The square root of 4 is 2. Square root of 4 is 2. That's 2 raised to the power of minus 3. Now, we are back to the negative index. For me to simplify it, I write this number as a reciprocal of this, the reciprocal of this in the positive form. Now this becomes 1 over 2 raised to the power of 3. 2 raised to the power of 3 is the same thing as 1 over 2 times 2 times 2. 2 times 2 is what? 4. 4 times 2 is 8. That's 1 over 8. So 4 raised to the power of minus 3 over 2 is the same thing as 1 over 8. Okay, we take the 7th example. 64 raised to the power of 2 over 3. Now, this one is the same thing as this. They are almost similar. What do we do here? We take the cube root of 64. So this is 64. Then square it. So the cube root of 64, like what we are saying, cube root is what number will I multiply 3 times to give me 64. That number is 4 because 4 times 4 is 16. 16 times 4, 64. So this becomes cube root of 64 is 4. 4 raised to the power of 2. 4 times 4, which is what? 16. So 64 raised to the power of 2 over 3 is 16. Alright, take example 8. Example 8 says 1 over 2 raised to the power of x equals to 8. Now we are going deeper into the into indices. Alright, 1 over 2, remember from your this fraction 1 over 2 can be written in a negative form. This is the same thing as 1 over 2 raised to power 1. And if I want to write it, I'll take the reciprocal. The reciprocal of this is the same thing as writing 2 raised to the power of minus 1. Then the power here is x equals to 8. Now, from here, when a number is raised to another power, which is raised to a power, a certain power is raised to another power, we multiply the power. So minus x times x, minus 1 times x is the same thing as 2 raised to the power of minus x is equals to, now the base here is 2. What I do to this 8 is to make the 8 have a base of 2 so that the base can cancel out and I equate the powers. Now 2 raised to the power of what will give me 8? 2 raised to the power of 3 is what will give me 8 because 2 times 2 is 4. 4 times 2 is 8. So 8 can be split into 2 raised to the power of 3. Now, the bases are now equal. I cancel it out. So minus x is equal to 3. But we are not interested in minus x. So I divide both sides. Divide through by minus 1. By minus 1. So this becomes minus x over minus 1 is equal to minus 3 over minus 1. Negative, we cancel negative. Sorry, 3 over minus 1. So x is equals to minus 3. So the value of x is minus 3. Alright, so we take example 9. Example 9, you can have something like this. 3, that's 3 into bracket 3 raised to the power of x equal to 27. Yes, something like this. 3 times 3 raised to the power of x equal to 27. Okay, now from here we can use the multiplication law. This 3 is the same thing as writing 3 raised to the power of 1 times, now this is 3 raised to the power of x equals 27. From the multiplication law, when we have something like this, it says we should add the power since they have the same base. This is 3, this is 3. They have the same base. The power here is 1, the power here is x. So let's add them together. So this is 3 raised to the power 1 plus x equals to 27. Now, I haven't gotten to this point. We have to break down this 27 to have the same base here. Now, this is 3 raised to the power of 1 plus x. Now, 3 raised to the power what will give me 27? 3 raised to the power of 3, because 3 times 3 is 9. 9 times 3 27. So this is 3 raised to the power 3. Now, they have the same base. I cancel out the base. So 1 plus x is equals to 3. I'm not interested in 1 plus x, I'm interested in x. So I subtract negative 1 from both sides. So this becomes 1 plus x minus 1 is equal to 3 minus 1. Minus 1 and plus 1 cancel out. So x is equals to 2. So x here is 2. Alright, let's take example 10. You can have something like this: 0.25 raised to the power of x equals 16. 0.25 raised to the power of x equals 16. Now this 0.25, make it to become a fraction. This is a decimal. How do I do that? I take the decimal point out. 1, 2. How many times did I move it? 2 times. So that's 25 over 100 raised to the power of x equals 16. Now 25, make it a fraction in the smallest term. That's 25 here 1, 25 here 4. So this is 1 over 4 raised to the power of x equals 16. Now this 1 over 4 is the same thing as writing 4 raised to the power of minus 1. The reciprocal of 1 over 4, 4 raised to the power minus 1. So this is x, our power, our index is still there. The same thing as this 16 can be written as 4 raised to the power of 2, because 4 times 4 is 16. So this is 4 raised to the power of 2. So minus 1 times x, that's 4 raised to the power of minus x, is equals to 4 raised to the power of 2. Now they share the same base. I can cancel out. 4 will cancel out 4. So I'm left with minus x equals 2. But I'm not interested in minus x. So I divide through by minus 1. When I divide 2 by minus 1, x will be equals to minus 2. So the value of x here is minus 2. Alright, let's take example 11. Example 11, we can have 3 raised to the power of x equals to 1 over 81. Now this one is already in the simplest form, or in the base form. Base form, 3 raised to the power x is equals to 1 over, let's split this 81. 81 can be expressed as 3 raised to the power of 4. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So now let's take the reciprocal of this. 3 raised to the power x is equals to 3 raised to the power of minus 4. You should be familiar with this by now. Now they have the same base, so they cancel out, they cancel out. So x is equals to minus 4. Right, let's take example 12, which will be the final example for this series. You could have something like 10 raised to the power x equals to 0.1234. Okay, or let's say 10 raised to the power minus x. Now this is a decimal number. We have to change it to a fraction. So this is 10 raised to the power minus x equals to, I move the decimal point 1, 1, 2, 3, 4, 5, then 6. So that becomes 1 over, how many times did I move it? 6 times. So 1, 2, 3, 4, 5, 6. This is 1 million. And 1 million can be written as this: 1 over 10 raised to the power of 6, because I moved this 6 times. Now from the, take the reciprocal of this, this becomes 10 raised to the power minus x is equal to 10 raised to the power of minus 6. Now 10 we cancel 10. So this is minus x equal to minus 6. Divide through by minus 1. So our x will be equals to 6. I hope you have learned today in today's lesson. If you have any question, anything you want me to attend to, you can put it in the comment section. Before we go, I will write down a list of take-home fun for us to do. Get ourselves acquainted with it. Practice. Mathematics is about practice. Remember, mathematics is fun. All right, before we go, these are the take-home fun, a list of questions you can practice at your leisure time. So I'll run through them though. Number 1 says 32 raised to the power of 3 over 5. So you remember the law to apply. Number 2 is 0.00001 raised to the power of 2. Number 3 is 343 raised to the power of 2 over 3. Number 4 is 2 raised to the power of x equals to 0.125. And number 5 is 25 raised to the power of 5x equals to 625. Number 6 is 10 raised to the power of x equals to 1 over 0.001. And number 7, which is the last, okay, this one is the same. Number 8 is the same as number 4. Number 7, which is the last, 216 raised to the power of 4 over 3. So let me know the answers in the comment section. If there's anything you need me to explain, drop it. Remember, mathematics is fun. If you have not subscribed to the channel, subscribe. Tell your friends about the Mickey Mouse class. Share it, like the video. Until we meet again in the next class, remain blessed, keep practicing. Shalom.